Okay, we are ready to set up our first program. You have your test bed all set up. So the first step inside the RobotC program, once you have the program set up, is to select the platform type. And if you do not see natural language PLTW, then you just need to select the VEX 2.0 Cortex. And when you do that, then the next time you open this up, you'll see the option of natural language PLTW. I'll select that, and then over here what has shown up is the natural language functions that I can input into my program that'll make this easier for us. We have pre-written programming language in here that we can drag and drop into our program and then just make changes inside that text or syntax of the program. So that was the first step. Then we want to go to Robot, download firmware, and set this to automatically update the Cortex. And here we have just a notice we're making, and I don't have mine connected, that's why I got that message, but just make sure that that is selected. Okay, we want to open our templates. So let's go File and Open Sample Program. And if you are not already in this folder, you might be in just Sample Programs, then we need to select VEX 2. And from there we go to PLTW. And this is the one we want, PLTW template. And there we go. So here is your code that you can put in there, and it's just read as text, okay, your comment line, and then we have a different type of comment line here, and we've already talked about those different types of comments. Okay, before we do anything, since this is a template, I want you to save this, and you could save it to your student drive, but I'm at home, so I'm just going to save it in the same folder. So I'll call this test program 1, and oh, I can't save there. Okay, I have to go to my documents folder, so I'm just gonna say robot, make a folder, RobotC programs, and now in there I can save. Okay, and you of course will have no trouble saving on your own drive because you have permissions for that. Okay, before I enter that information, I want to set up my motor and sensors. So I click on the motor and sensor setup button, and here I'm going to select the GTT test bed. And when I select that, you'll see your test bed there, and what it does is it automatically sets up my sensors and motors. So you can see the sensor ports. They have the line follower, potentiometer, limit switch, bump switch, and your green LED. And then the motor ports, you have claw motor, right motor, and left motor. You'll notice that the motors are 3-wire motors, but we actually have 269 motors. So we want to change these 3 to VEX 269 and hit apply. Okay, and then you'll see all of our configuration is set up for us. If I go back to standard, you'll see that the GTT has disappeared, and that's simply because we changed something in that, that pre-configured setup. So now we hit OK, and in our program we have all of that information, so we know now when we're writing our code if we need to reference what we called that item or within the setup, all of our connected components. The motor here is called port 1, and motor here port 2, and port 3, and then right here we know that's the claw motor, the right motor, and the left motor. Okay? Now it's time to go ahead and put your information here in your comment section. So your project title is, let's do test project 1. And team members, so your names, the date, and today is 4/25, your section, so the period that your class meets, and then the task description is running our first program. And remember that pseudocode is actually common language for what your program is doing. So for this first task, we need to switch over to the PowerPoint and find out what we're doing in this first program. So I'll do that right now. Now, before I tell you what we're actually doing in our first program, I need to go over just a few things. The programming we are doing is called behavior-based programming, and what it means is every single thing that robot is doing, we need to identify step by step within the code. So behavior is anything the robot does, turning on a motor, moving forward, tracking something, navigating through a maze. And then there are 3 main types of behaviors. The basic behaviors, that's simply turning something on, telling it what it is that is on the robot that is being identified as the component that we're working with. And the simple behaviors, that would be telling this basic behavior or that component what to do. So something like moving forward or tracking a line. And then complex behaviors, a robot performs a complex task or solves a maze. That would be an example of putting your simple behaviors together to achieve a more complex behavior. So complex behaviors, they can always be broken down into simple behaviors, which then are broken down into basic behaviors. So here's an example. If I wanted the robot to navigate this maze and I go step by step, I need to tell the robot every single thing I want it to achieve. So here, if I'm going through, going through that maze, the complex will go from start to the goal. So here, breaking it down to the simple, I would have the robot that's starting here, I would have it first move forward, then it turns left, and it doesn't do anything until I tell it, once it's turned left, to then move forward, and I would tell it how many seconds, and then it will turn right and tell it how long it needs to turn right and move, not how long it needs to turn right, but rather how long it needs to move forward, and then turn right again. And if we're going into the goal, I need yet to say move forward. Okay, then the basic part of the command is starting the motor at 63 for 2 seconds, stopping the motor, starting the motor, turn left, stop the motor, and so on. So it's step by step. And pseudocode. So just in reference, our pseudocode, remember, is our common language for what we are about to accomplish. Okay, it's almost code, but not quite, and it's a good point of reference as you're writing your code. You can go back up and ask yourself, now what am I supposed to be doing step by step again? And your lines of pseudocode should be listed in the same order, of course, as they will appear in your program. Looking at the natural language, we're going to be looking inside the function library and just grabbing code and putting it into our program. And it makes it a whole lot easier for you because you don't have to know how to write the C language. You just will, at first at least, you'll just be replacing some of the generic text within those commands. You drag it and we'll replace some things with specific information for our setup. Okay, it saves a lot of time, a lot easier, and you don't have to remember all of the rules for writing code. Movement is within that natural language. So if you opened movement, you'd see that that's where we find our start motor and stop motor. Inside the special section of the natural language, that's where we'll go to turn our LED light on and off. Within the until section, we would use some of those commands for programming things like our bumper switch or push button and our potentiometer, so that it doesn't do anything until it's actually pushed or bumped. And then the wait command, of course, a very important command, because if we just turned our motor on and off without a wait in between, you wouldn't even see that motor move. It would actually read it, it would turn it on and turn it back off, but it would happen so quickly that you wouldn't even see any movement on the motor. So starting a motor at speed 63 would be your half speed, and then you have to say wait for 3 seconds to run the motor for 3 seconds. So let's take a look at the program we're going to run. We're going to start the motor. We're going to run it at half speed at 63. We'll tell it to wait then for 5 seconds before it stops the motor. Okay, that is our first program. Remember that the program has to go inside those curly braces, and it needs to be in order from top down. So we're going to switch over now back to RobotC, and we'll enter all of our information. Okay, so your pseudocode, you know what you're doing now. So you want to go ahead and write in what you're doing from beginning to end. We're going to start the right motor, wait for, whoops, that's actually a separate command. Let's put that on the next line. Wait for, do we say 3 or 5 seconds? Let me go take a look quick here. Wait for 5 seconds. So then we'll stop. Wait for 5 seconds. Stop the right motor. Okay, and now we'll put in our command. Okay, let's go to the first line after the curly braces, and we need to start the motor. So we grab the code from movement under natural language, and we just drag it in here. Okay, and remember, it's just in generic terms right now, so we need to tell it which motor, and that's where it's nice. We can go up here and look and see, oh yeah, that's right motor, all lowercase except the M on motor. So we'll type right motor, and the speed is 63, that's half speed, and go right after the semicolon, hit enter, and then we need to wait for, here we said 5 seconds, and notice in the wait we have wait time and then we have milliseconds, so we know we're talking in regular seconds here. So we're going to have it wait 5 seconds, and then enter again, and now we need to stop the right motor. Okay, and with my entries, I have extra spaces, which doesn't matter in the program. It doesn't read spaces, but just to make it look nicer, I took some of those spaces away. And then the last thing is to compile and download the program. So I'm going to show you what that should look like. I can't download it right here. It's going to give me an error because I'm not actually connected, but I have a video of what that will look like. So let's go take a look at that. Okay, it's difficult to see, but it's actually now running at half speed, and then waits for 5 seconds, and it's done. Okay, your turn. Good luck. If you have any error messages, then remember that you have your help section here. Right here, open help, F1 would be your best bet. And then you have a few other choices here. And hopefully you can get that to run, and then you can go on to the next video.